Hello and welcome back to another Prismatica devlog. Today we're going to be talking about the damage, health, armor systems in Prismatica. We're going to cover how we get accurate character collisions, how we do weapon tracing and determine what parts of the weapon are hitting, your opponent and all that kind of stuff. And also how all of the armor ties into that. We're also going to be looking at how the limbs of each character, determine their health and how we apply debuffs based on, if your arms are hit or if your legs have been shot full of arrows or something. So without any further ado, I think we should just jump in to the session. And we're going to kind of talk about why we're going into such depth with, the damage and the armor and all of this stuff and what the kind of goals of these systems are. I think it's always a good idea to kind of outline some emotional goals of a gameplay system rather than, I want it to be math, numbers. I think it's more wise to have goals like I want the player to feel XYZ or I want the player to think XYZ. So the first thing that I want players to feel through, the health and armor system and stuff is player feels skillful. Skillshare, also known as the sponsor of today's video. Skillshare is your one-stop shop for learning absolutely any new skill that you could possibly want to learn. If you've ever dealt with burnout or you're just tired of doing the, same old game dev stuff over and over again, a really good way to actually break out of that is to learn a new skill. For example, picking up a synergistic skill like illustration or 3D modeling can really be helpful as a game developer, even if it is just to understand all of the puzzle pieces that go together to making a game. For example, when I clock off for the day working on Prismatica, I like to sit down and learn. One of the more recent classes that I've gone through is Writing Fiction, 5 Exercises to Craft a Compelling Plot by Lisa Ko. So if you're looking to learn a new skill, the first 1,000 people to use the link in the description or use code Prismatica Dev during sign up will receive 1 free month of Skillshare membership. Thank you once again to Skillshare for sponsoring today's video. So the first thing that I want players to feel through, the health and armor system and stuff is player feels skillful. The way we kind of achieve this through the armor system is by having accurate armor hitboxes. So players can aim for the weak spots on enemies. Players can aim for specific limbs / weak spots. Keep in mind, when I say skillful, I mean mechanical skill. As opposed to number 2, player feels knowledgeable. So this would be things like different damage types. Armor has specific weaknesses, strengths, and kind of rewarding the player for noticing trends in what damage works against what armor types and specific enemies and all that kind of stuff. And I guess the third thing that I want players to feel is, oh shit. So, a little player story might be player is trying to outrun some dogs, some Dark Souls dogs. Player gets bitten on the leg. Player can't run. And then, as a result, the player must adapt to a new situation. I guess this is kind of like player feels strategic? Player feels strategic. And, these two specifically tie into, the armor and equipment system because maybe players keep getting hit in the head, they keep getting shot in the head and dying, and so they're like, maybe I should wear a better helmet or a helmet with, a face guard, even if that means there's downsides like, reduced stamina and reduced aiming capability and all that kind of stuff. Hello, my cat. Are you a cat? Just be nice. Just be nice. So with all these points in mind, let's begin our discussion on how I actually achieve these through the systems in the game. So the first and most crucial thing about this entire system is how we deal with character collisions. So if we just jump into the game real quick, for example, I'm going to stab this guy somewhere in the chest. Oh, I got him just in the shoulder, right clavicle, chest front, right armpit, good shot, pelvis front, the left thigh, the right thigh, etc., etc. Now, we talked about why we want to go this deep into, you know, the hitbox accuracy and whatnot, but let's actually talk about how we do it. Now, there are a few ways to get accurate, you know, hit collision for characters and stuff. You could try doing something with per poly collision, like complex collision. I'm not sure how well that works with skeletal meshes, or if it does work with skeletal meshes at all. But even if it did work with skeletal meshes, it would still be hella expensive. Per poly complex collision wouldn't give us any details about, you know, is this armor, plate armor, is it chainmail, is it blah 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 blah, unless we were doing something with heaps and heaps of material slots that all had their own, you know, physical material that we could query from the line traces. Now, the other way we could go about getting super accurate collisions is to actually add more colliders. So, you know, we could have a collider here and a collider here and a collider here for the chest front and chest back and all that kind of stuff. But one of the issues that we would run into pretty quickly with that is that when you hit a collider and you get the hit bone name from the hit result, it'll give you the resulting bone name that it was attached to. So even if you had multiple colliders attached to the spine or something, they would all return spine 03. Now, you could get around this by adding extra bones in the actual armature of the character that just kind of go in parallel to the other bones. So, for example, this elbow bone here is actually corresponding to the twist bone of the upper arm. So you might be wondering, hey Charles, if hitting a capsule with a line trace just returns the name of the bone that it's attached to, how do we actually get the, you know, the chest front, the chest back, and the elbow and the elbow pit and the wrist and the forearm and all these different hit zones? Well, the answer is using math. So if we go to our damage handler component, which is sort of the component that deals with the flow of damage through a character, we're going to look at this determine body hit section. So this function gets the hit bone name from a hit result. So for example, let's say we shot an arrow and it hit a character in the front of the neck. This hit bone name would be the neck 01 bone. Neck 01. And so we're going to feed this hit bone capsule name into a map that we've prepared beforehand. Now, this map comes from a data asset. So each sort of creature type will have its own body hit section data asset, which is basically just a big list of all of the hit sections, all of the hittable sections of a character. So you can see here we have the head bone, so the head capsule bone name, and contained within the head bone, we have the head top and the head bottom. And if we go to something like spine 03, it has the chest front and the chest back. And if we go down to something like the lower arm right, it has the right forearm and the right wrist. And like I explained earlier, the twist bones of the upper arm are the elbow and the elbow pit. So we've got the hit bone name, neck 01. We've found an array of structs from that bone name that correspond to it. So we're going to loop through each of those hit body sections, and we're going to do some math. So to cut a long story short, basically what we do is we get the center of mass of the capsule that was hit. So you can see where this widget is, the little mover widget. That's the center of mass of the capsule. And essentially all we're asking is, compared to this location, is the hit result positive in, you know, the Y direction, positive in the Z direction, or the X direction, you know, is it positive or negative? And that way we can tell if it was the front side or the back side of the capsule in any given direction. And the way we actually specify this really easily is we have a thing called the bone collision section vector. If it is 1, it means it's positive in that direction, so X1. And if it's 0, it means ignore them completely. So the head top is, you know, positive X, and the head bottom is negative X, relative to the actual bones transform, not in world space. Now, this also means that we can have multiple directions. So, for example, we have the pelvis front and the pelvis back, but then we also break it up further into the groin and the buttocks. So to go back a step, we get the array, we loop through the array, and we find the hit section name that corresponds to whatever the vector is. So we just do this little kind of comparison, and if it's true, return with the hit section name, and also what the limb that each section belongs to. But I always feel like Professor Quirrell from the first Harry Potter movie when I take my hair out. Potter! So the way that armor is currently set up is the characters have an equipment component, which basically just stores an array of references to some objects. But before we go any further, it's probably worth explaining how armor is set up, code-wise at least. So, for example, let's look at this chain Hauberk, and you can see that it's just a list of those body hit sections that we've defined in, you know, the character damage handling component, which basically just specifies what kind of armor is covering this part. You can see that the body is all covered by chain, and also the thighs a bit, but the arms are just covered by gambeson. So we want to be able to differentiate between, you know, what parts of the body are covered by what kinds of armor, rather than just being like, oh, if we hit all of this thing, you know, it's always plate armor or something like that. So you can see that the chest front is covered by chainmail and gambeson, so it's got 2 layers, this armor. And basically all we have to do is go through all of the bits that it covers and what it's covered by. Now, this does look like a lot of data to be entering manually, and it kind of is, but we can set up templates that make it way faster, where, you know, we've got like a default chest armor, and then all we have to do is just go through all of the hit sections that have already been set up and just be like, okay, this is, you know, gambeson armor, or this is chain armor, or this is plate armor, or this is, you know, brigandine, or something like that. So moving on from that, when we actually equip a new piece of armor, or we, you know, spawn some armor on another character, we need to update a hit section to armor object map. So this is just a map that maps a body hit section, so chest front, neck front, you know, left forearm, whatever. And it's going to go through all of the armor pieces that are currently equipped, and it's going to find those pieces of armor that cover that spot. And the reason we do that is because it just makes it a lot easier, rather than looping through an array and checking an array within an array if it matches, you know, this thing. We just kind of do it the other way around, and we offload all of that kind of heavy processing to like this one-time function. So when we actually do get hit, we notify the armor of hit through the equipment component, and this is going to loop through all of the armor covering hit sections, and it's going to do an armor calculation for all of the armors that are covering that spot. So we pass in the damage and the hit section, and we do the armor calculation. We then spit out the new damage value after it's been deducted, and then we do it again. So we pass it to the armor that is underneath that armor, if there is any, and when that's all done, we get the final damage value, and we spit that out back into the damage handler component. Now, inside this armor calculationator, all we do is we have the body hit section, and we get the armor itself, so, you know, the chest plate armor, whatever, and we're going to find what armor types are covering that position. So if it was a chest plate, it might be plate armor and a gambeson underneath it. And then we determine if the armor was successful. So we're gonna decide yes or no, did this armor block any damage? Currently, this is determined by the durability of each section. So if a piece of armor has 100% durability, then it's always gonna block damage and, you know, reduce it by a percentage. But the more it gets damaged, the less chance it has to actually succeed. So you could think of that as like if we had some chainmail and someone kept hacking away at it. As they're hacking away at it, you know, it's going to be stopping all of the slashing damage. But as it starts to break apart, there's a chance that, you know, the opponent's weapon might just completely bypass that and, you know, deal full damage. So if the armor is successful, we then, well, we spawn some particles depending on what the armor's made of, blah, blah, blah. We deduct some durability from that section of the armor, and then we reduce damage based on a few factors. So if we go into the reduce damage function inside the armor calculation function, then you can see that we get the armor type. So, you know, is it plate mail? Is it chain mail? Is it just cloth? Is it just regular clothing? Whatever. And each armor type has its own damage absorption values. So in a folder somewhere, you can see we have a bunch of data assets for, you know, brigandine, chainmail, loose fabric, tight fabric, gambeson, hard leather, lamellar, plate armor, soft leather, etc. And each of these have their own absorption values. So something like plate armor absorbs 100% of the slash damage, 100% of the pierce damage, and half of the impact damage. And then below that, you can see what causes durability loss for this armor type. So if plate armor keeps getting bashed with impact damage, then it's more likely to start breaking than if it was just getting cut with a knife. So as an extra layer on top of the armor type, we actually have material types. And this is just a nice way to kind of do some sort of procedural generation of armor and weapons, but to have it be consistent with, you know, what you're visually seeing. So imagine we have, you know, some plate armor, but it's made of gold or something, which is, you know, a very malleable metal that's quite heavy. It might have extra impact damage absorption, but since it is more soft and malleable, maybe it's less resistant to pierce damage. So essentially the materials are a modifier for the armor's effectiveness and the armor's absorption. And the materials and stuff also apply to weapons, but we'll get into that a little bit later. So we get the armor types, damage absorption. We get the material that it's made of's damage absorption, multiply them together, and then we 1- them, and we make sure that they don't go over 1. So the reason we clamp these to 1 is because we might want to have some armor type that has like 200% slash absorption or something, so that even if that's made of a weak material type, it still doesn't drop below 100% absorption. But the reason we clamp it at 100% is so that we're not healing characters when, you know, they get hit with something. So after we have the values, you know, that we want to reduce it by, we just multiply the incoming damage by those values, and then we pass that out back into the armor calculation function, and we set that as a local variable. And so the resulting physical damage gets passed back around, and blah, blah, blah goes through, and then the next armor, you know, if there's armor underneath the top layer of armor, it will then be using that reduced amount to deduct its durability and then reduce the damage even further. And then when that's done doing all its calculations, that gets spat back out into the equipment component, and it goes to the next piece of armor that may have been covering it. So if we hit the pauldron, then it would calculate, you know, the pauldron, it would reduce its damage, then it would pass it to the chest, because the chest covers the shoulders as well, which, you know, let's say they were wearing a chainmail with gambeson underneath, would then reduce damage for the chainmail, and then it would reduce damage for the gambeson, and then that would be dealt to, you know, the shoulder of the character. If, for example, we stab this person in the chest, you can see that we dealt, you know, 6.4 damage. We hit this person in the stomach front. They were wearing chain hauberk, and it had chainmail armor and gambeson armor. If we hit that exact spot again, there we go, we hit them in the stomach front again, and this time the chainmail didn't actually block any damage because I'd previously damaged it, so you can see that we dealt 10.5 damage. So let's say a character is wearing like full plate armor, but they're not wearing a breastplate, they've got, you know, chainmail on the front of them. If you keep hitting that same spot over and over again, eventually that piece of the armor will break or be, you know, less effective, and they'll start taking, you know, full damage. So again, it rewards player mechanical skill. You know, if you're accurate enough to keep hitting the same spot of an enemy over and over again, then eventually you'll start dealing, you know, full damage, and you'll be able to defeat them quite easy. You can also see with the armor of the characters, oh god, that was savage. You can see with the armor of the characters, when I hit them in, you know, the chainmail, you can see the sparks and stuff that fly off. And the color of the sparks at the moment is corresponding to, you know, the material type. But the reason that we go a little bit overboard with the particles is so that you can get that feedback of, you know, I hit the armor of the character, whereas if I hit this guy in the leg, it's just like blood and like a little dust puff for, you know, the cloth armor and whatnot. Oops. Hello, I'm Charlie from the future after editing this entire video, and I have actually decided to break it up into 3 parts. Today we looked at the goals of the systems included in these devlogs. We also looked at how we do complex collisions very performance efficiently. And we also looked at how we assign armor all of its values for what it covers, and how the equipment component knows what armor to query, and how all of the armor stuff works. Next time, we're going to be looking at how weapons are randomly generated, how they deal damage, how we determine what damage is being dealt, and then we're also going to look at the limb system for the characters, so all of the debuffs when they, you know, get hit in certain spots and what that means, and how that's going to affect the player and how it's going to benefit the player if they play their cards right. So I hope you are looking forward to the next part, which will be about a week from now. And don't forget to check out the link in the description to get your free month of Skillshare. And I guess with that, we say goodbye. Goodbye.